Good morning to all my dear students. I hope you all are fine. Children, we were doing chapter 12, current electricity, and we will continue this chapter today again. Children, these are the topics that we have covered till now: electric current, then charge, properties of charges, and electric current. Today, we are going to start with a new topic. But before I introduce that new topic to you, I will like to discuss certain examples and then we will move to the new topic. In example 1, you can see there are two beakers drawn, beaker A and B. Beaker A consists of water and beaker B is completely empty. In between, there is a stopper so that the flow of the liquid can be regulated according to our need. Now, when the stopper will be open, now it is closed. So, when the stopper will be open, at that time, the water will rush from one portion to another, right? And from which portion it will rush? It will definitely rush from beaker A to beaker B. You can see here, children, that when the stopper is pulled up, at that time the water rushes from beaker A to beaker B and it keep on shifting from one beaker to the other beaker. Now this process will continue. How long? You can see the level of water in A is decreasing. So this process will continue till the level of the water in two beakers become equal. Now you can see that the level of water in two beakers have become equal and therefore the water is not flowing. Now from this example we can conclude that whenever there is a difference in the level of water, the water will flow from one portion to the another portion. That is from higher level to lower level. That is the flow of energy also. The rule that the energy flows always from higher to the lower level. So because of the difference in the level of water, the water flows from the higher level, that is beaker A to beaker B, till the time both the levels become equal, right? So unless and until there is a difference in the level of water, the water is not going to transfer from one place to another. Now let me give you one more example. This is example number 2, and in this you can see that the inclined plane, there are two blocks are kept and they are inclined at different angle. The block A is steeper and block B is less steep as compared to block A. Two balls are kept on the top of these two blocks, and when they are allowed to release, fall down, then the speed of which one will be greater? Of course, the speed of the ball which is kept on block A will be greater because the angle of the steepness is quite more as compared to block B. So the variation in the speed will be because of the difference in the angle. So children, from this example, what can we conclude? The speed of the ball is due to the difference in height. Now coming back to the portion of our chapter, this is an electric circuit, children, where we have attached these few components like bulb, ammeter. You can see that ammeter is connected with the battery with its positive terminal with the positive terminal of ammeter. Now in this circuit, the current is flowing, the key is closed and the bulb is glowing also. The question arises that the electrons, we have already read that the flow of the electrons is responsible for the establishment of the current electricity. Now the question is that the electrons that flow from one terminal to the another terminal, now which component here in the electric circuit gives the power to the electrons so that they can move from one terminal to another terminal. Just like children, we have seen in the two examples that unless and until there is a difference in the level of water or difference in the level of height, the ball or the water does not move from its place. If the level is equal, then it is not going to move. Similarly, the electrons, that is which flow, that the current that flows from one terminal to another terminal in an electric circuit, that is also a type of an energy, electrical energy, right? So the energy needs to be flowing from higher level to lower level, or from a higher potential to a lower potential. So this is what we are going to study today. What is the factor that is actually helping the electrons or the electrical energy to move from one terminal to another terminal? This factor is known as potential difference. Now potential difference is defined as the amount of work done to move a unit charge from one terminal to another terminal in an electric circuit is called potential difference. You can see the formula is given a mathematical form. Potential difference is equal to the amount of work done per unit charge. So here we have a electric circuit also, children, and you can see here that in this electric circuit the amount of charge that flows from one terminal, like we know what flows from one terminal to another terminal, the electron flows. So electron flows from negative terminal to the positive terminal. The electrons, you can see, they flows from the negative terminal of a battery to the positive terminal. They move from here to here. Now when they move from the negative terminal, the amount of work which is done on a single charge to make it move from this terminal to another terminal, that is positive terminal, that is counted as potential difference. And because of it, the definition is written like this, that the amount of work done to move unit charge from one terminal to another in an electric circuit is called potential difference. The symbol used for potential difference is V, work done W, and charge Q. So V equals to W upon Q. The SI unit of potential difference is volt, which is represented by V. The smaller units are millivolt. 1 millivolt is equal to 10 to the power minus 3 volt, and microvolt, 1 microvolt is equal to 10 to the power minus 6 volt. So in this today's topic, we have concluded what is potential difference, its definition, its SI unit, smaller unit, and the formula of it. Thank you, children.